guys, welcome to my basement. All right, so we're doing 10-2 today, which is simplifying radical expressions. So a radical expression is any expression that contains a radical sign. So we need to get it into simplest form. So there's three things that we're looking for. No radicands have a perfect square factor other than 1. No radicands contain fractions, and no radicals appear in the denominator of any fraction. Okay, we're going to start with number 2, and then we'll get back to number 1. So you're going to break down your number. You can use the factor tray, but when you break it down, if you can think of a perfect square that goes into the number, then you're like helping yourself along. So what times what is 54? 9 times 6. So since 9 is a perfect square, I'm just going to take the square root of 9, which is 3. So that goes on the outside of my radical sign. And 6 only breaks down to 2 times 3. So that doesn't help me with a perfect square. So this 6 has to stay on the inside of the radical side. So then 80, if you can't think of any perfect squares right away that go into it, use the factor tree. So 8 times 10, 10 is 2 times 5, 8 is 4 times 2, and then 4 is 2 times 2. So I see that I have a set of 2's here and a set of 2's here. So since I know that 2 times 2 is 4 and it's a perfect square, I take it out as a 2. Since I know that this 2 times 2 is 4, which is perfect square, I take that out as a 2. So 2 times 2 is 4. So on the outside I have a 4. On the inside, the only thing that's left is this 5. So the answer is 4 radical 5. Here, you could multiply them first, but it kind of doesn't make sense because we're just looking to break everything down. So 14 is 2 times 7, and when I multiply that by radical 2, I have that 2 here. So I have 2 times 2 times 7. Here's my set. 2 times 2 I know in the back of my head is 4. Take the square root of it, which is 2. So my final answer is 2 radical 7. Then on this one, same thing, 90 is 9 times 10. 9 is a perfect square, so the 3 goes out. And I'm going to leave myself room because I don't know what's going to happen with these variables. This 10 stays on the inside. When I take the square root of x to the 3rd power, I'm remembering that it's x times x times x. So I have one set, so that goes on the outside, that goes on the inside. Y to the 4th, so if you have 4 of them, if you take the square root, you'll have 2 of them. Z to the 5th, same thing. So I'm going to have z to the 2nd on the outside and just z on the inside. And that's my final answer. Because I'm thinking about sets. How many pairs do I have? So I have 2 pairs of z's with 1 left over. There's the 1 left over. Now this one has something important in it. So anytime you have a even exponent on the inside that's with your variable, when you bring it to the outside, if it's an odd exponent, it needs the absolute value sign. It has to do with a negative times a negative is a positive, and we don't know what this variable is. So first we're going to start with the 32. So when I break down 32, what am I going to break it down to? So we can do 8 times 4, and this is going to be 2 times 4. So I can take the square root of both of those. So the square root of that is 2, the square root of that is 2. Multiply that, that gives me 4. So I have the 4 on the outside, this 2 stays on the inside because it's left over. Now here's where that rule comes in. This is an even. When it goes out, it's an odd because it's just r to the 1st on the outside. So I need the absolute value sign on the outside of the r. This k to the 4th goes on the outside as k to the 2nd. T to the 5th goes on the outside as t to the 2nd with 1 t left over. So this is the only one that was even and then odd. So that's the only one that gets the radical sign. Now here, we cannot have a radical in the denominator because what this really is radical 35 over radical 15. So in order to get rid of a radical on your denominator, multiply the top and the bottom by your denominator. So radical 15 times radical 15 is just 15. Then on the top, we have to break all this down. So what I'm really doing is radical 35 times radical 15. So I'm going to break down the 35 and the 15 next to each other. So 15 is 3 times 5. 35 is 7 times 5. Do I have a pair? Yes, I do, the 5. So the 5 goes on the outside. On the inside is what's left, 21 over 15. Then make sure you check to see, can I simplify this? Yes, I can. 5/15 simplifies to 1/3. So my answer is radical 21 over 3. This cannot be simplified because that's under the radical sign. So this is all you can do here. Okay, on the bottom, we're rationalizing the denominator. So it's similar to the question above it, whereas you can't have a radical on the bottom. So how do we get rid of that? We have to multiply the top and the bottom by the opposite of what we have here. So we're going to multiply the top and the bottom by 5 minus radical 2. So on the bottom, you're really foiling because it's a binomial times a binomial. Remember, they're the same, but they're opposite. So I square the first term, square the second term. Radical 2 times radical 2 is just 2, and it's always going to be a minus. So on the bottom, 25 minus 2 is 23. On the top, you're doing the distributive property. 3 times 5 is 15. 3 times negative radical 2 is negative 3 radical 2. Look at the end, see if there's anything you could simplify. The only way you could simplify it is if all 3 of these had a common factor. Since they don't, we're done. Okay, next one. So first thing you need to do is get rid of that radical in your denominator. So you're rationalizing the denominator. So we have to multiply the top and the bottom by the opposite of what we have down here. So we're going to multiply by 2 minus radical 2. 2 minus radical 2. So foiling, 2 times 2 is 4, minus 2. So on the bottom, we have 2. On the top, distributive property. 3 times 2 is 6, minus 3 radical 2. Then I bring it over. Do I have a common factor here? Yes, it's 2. So divide everything by 2. 6 divided by 2 is 3. No, I do not. I'm going to leave it. That's my final answer. And last one. Okay, so now I'm going to multiply the top and the bottom by 3 plus radical 7. So on the bottom I have 9 minus 7, which is 2. On the top, do the distributive property, I get 21 plus 7 radical 7. Bring that over and check to see if there's anything I could do to simplify. This does not go into all 3 numbers, so that's my final answer. And that's it.